Hi Professor, here we are three members, Aditya, Praveen and Vibha as a team did our project too. Myself, Aditya, I'll talk about application choice and security analysis. Um, we have chosen one of the cloud computing platform, DropBox, as application in our project because we do see that nowadays number of organizations and individuals are trying to utilize the advantages of cloud computing without sacrificing the data privacy and security. So we decided that Dropbox would be a great platform to analyze and implement different security methods. Now I'll tell about different highlights and security analysis that we implemented in our project. The first one is the secure server storage, Dropbox, as I mentioned earlier. The next is we have followed AES block encryption with OFP mode of operation to secure application from data eavesdropping attacks. This works like this, like for Dropbox file transfer functionalities like upload and downloads. Whenever a user wants to upload a file into the Dropbox, the application performs encryption and upload the encrypted file onto the Dropbox. And whenever the user wants to download a file, it downloads the encrypted file and decrypts and gives it back to the user. The second one is SHA-2 cryptographic hash function. We have followed this approach to secure the application from data modification attacks. For example, it works like the application computes the hash of the downloaded file and it compares the results to the previously published hash result, and it will show the user whether the file downloaded has been modified or tampered. The third approach we have followed is two-factor authentication. This secures the application from data replay attacks. Basically, we are making use of Dropbox. Dropbox API's two-factor authentication, that is the login, as well as the security code, that is the one-time password for the user to log into Dropbox. And now Vibha will talk about more details on how each of these methods have been implemented, and Praveen will talk about the application's implementation validity and will show you a quick demo.
Just encryption is not sufficient to make sure that the data which was uploaded is the one which is being downloaded by the end users who have the keys. So we've used the MD5 message digest algorithm for data integrity. It's a widely used cryptographic hash function producing a 128-bit hash value. It has been utilized in a wide variety of cryptographic applications and is also commonly used to verify data integrity. Now that we've discussed our choice of encryption and MAC algorithms, let's come to the implementation details. We have used AES and MD5 to secure our chosen data processing application, which is DropBox. These make sure that the data being transmitted is secure from eavesdropping, replay attack, and data modification. On the screen you find the block diagram of how encryption is being done to secure our application. You see that the authorized block takes two inputs, sample key K and input file name IF1. The file name OF2 is generated. It is the hash value of input file IF1. The key FX is generated by a combination of the sample key K and input file IF1 and is thus unique for each file. In the authorized block, it generates key F, also used by AES. It then generates file FN3, which is equal to output file OF2, which is used to uniquely locate the file on the server. In the AES block, the file F1 is first appended by its hash value and then encrypted to get the file F2. Moving on to decryption. As you see in the block diagram, AES decrypt produces file F3 using the key which was shared. The keys are shared with all the authorized users. The decrypted file and its integrity is checked by comparing the hash value of F3 and hash. If the values match, the file is authentic. Praveen will further explain the validity of our implementation and give a quick demonstration.
Hi, I'm Praveen. Welcome to the Applied Cryptography Project 2 demo. As you can see, I am currently in the project folder. There are all these files in this current folder. So there are we have considered three types of security measures in this project. One, security and privacy using AES block encryption. Two, we have used the MD5 hash function to authentication and to check whether the data has been modified or not. And three, two-factor authentication. So I'm gonna show you when these encryptions happens in the process. So starting with, if you see the list of files here, so we have the authorization file, so which basically uses MD5 hash function in order to authenticate the file. To start the process, you have to do /authenticate, and then you have to pass a sample key. I'm going to pass a sample private key and then input text, which we have to encrypt. So if you do this process, so it shows like 250 bits were written to the shared key, and you can follow this shared file if you want to see the shared file, right? So let's stop this process and let's see what are the files inside. So we can see the new file has been generated in the end. So if you want to see the input file, we can just open the input file and see the contents in it. So this is a plain text file. There are no encryptions happened here. So you can read the entire file. So the next step is to upload the input file to the Dropbox. So if you see the list of files, this .share file has been generated in the end. So this file has been generated using MD5 hash function on the input file using sample private key. So the second step is to upload the input_text file after encryption to the Dropbox. So to do that, all you have to do is /preprocess and then give the share file name and then input file name. So now comes the two-factor authentication step. So what we have to do here is copy the link, go to the browser, open a tab, this project to access Dropbox files. So I'm going to allow it. So it's giving a unique ID here. So why we call it a two-factor authentication is the first step involved is I have to log in as with my username and password. That is the first step of authentication, and the second step of authentication is to give this unique ID, so using which you have to upload the file to the Dropbox. So I'm going to copy this code and then go to the terminal and paste it here and click enter. Then you can see here the following file has a local copy and also uploaded to the Dropbox. So to see whether the file has been uploaded to the Dropbox or not, go to the browser and see the file list. So if I just refresh the file list, then you can see the file here 15 seconds ago. So this is the new file which has been uploaded to the Dropbox. So the last step in this process is to get the file from the Dropbox and decrypt it. So to do that, we have to run the recover file using the hash So once I run this command, so it is asking me to authenticate using Dropbox. So if I open this URL, Dropbox is going to give me a unique ID. Hello the project. Paste the ID and click enter. So you can see here downloading file from the Dropbox, and then integrity has been satisfied. So only then the file will be decrypted and returned to the new data file. So to see the encrypted file, so go to the Dropbox and try to download the file. I'm going to save it to the downloads. If I want to see the contents of the file, go to the downloads and try to open the file. So as you can see, this is not a clear text as it has been encoded using AES encryption. So you can close this file. Now coming back to the project, so if you want to see the contents of the decrypted file, see the list of files in the folder. So you can see this .data file has been generated in the end. So if you open this file, so you can see the contents inside, which are in readable format, which has been decrypted using AES decryption.